This is an example of an equilibrium. The first thing you need to know is that the left side are called reactants and the right side are called products. The two arrows pointing opposite ways is a symbol for equilibrium. Now, what does this chemical formula mean? As you can see, the carbon is a solid substance and it's inside the house of hydrogen. In result, this causes a synthesis of methane or the production of methane. This reaction is also called a forward reaction. With the reaction of carbon turning into methane, methane also turns back into carbon. You'll see why. Methane turning back into carbon is a reverse reaction because the forward reaction is reversed. Forward reaction and reverse reaction both have their own rate within their reaction, and when both of these reactions are at the same rate, it is at equilibrium. But as shown on the graph, we can see a point in time when the forward reaction and reverse reaction aren't at the same rate. This means that the system is not at equilibrium. A way we can tell if the reverse and forward reaction aren't at the same rate of change is by knowing an equilibrium's constant and the reaction quotient. The equilibrium constant is the constant when the equilibrium is at equilibrium, and the reaction quotient is the constant at any given time. And an important thing to note is that the solids and liquids are never included in these calculations because they are constants and don't have changing concentrations or pressures. The formulas for equilibrium constant and reaction quotient are the same but just different concentrations of the same substance. Formula for equilibrium constant is literally products over reactants, with the products being the left and the reactants being at the right. So for the methane equilibrium, it would be this. The exponent of 2 for hydrogen is because the coefficient for hydrogen in the chemical reaction is 2. Formula for a reaction quotient is also products over reactants, which is this. So again, same formula, different concentrations, or pressures if dealing with gas, for each substance. If reaction quotient is less than the equilibrium constant, then the equilibrium is lacking in the product side, since the products is the numerator, and the higher the numerator, the higher the number for the reaction quotient to match with the equilibrium constant. And vice versa if the reaction quotient is more than the equilibrium constant. And that is half of a whole unit in AP Chem explained in just 2 minutes.